Welcome. We are in Algebra 1 in the second unit, solving equations and inequalities. And we are on multi-step linear inequalities. That's our problem set. This one says, solve for x. Reduce any fractions to lowest terms. Don't round your answers, and don't use mixed fractions or mixed numbers. So, here's an inequality. It's an inequality because instead of having an equal sign, which would make it an equation, it has this symbol which means less than or equal to. So, inequalities include not equals, less than or equal to, greater than or equal to. So these are the different symbols that could be part of an inequality. In this case, the left side of this equation, 4x plus 4, is less than or equal to the right side, which is 9x plus 8. So the way we go about solving this is essentially the same as the way you would solve an equation. And so what we want to do is get all our x's on one side. We would like those to be positive. And that actually matters a little bit more when we're doing inequalities than when we're doing equalities. And we'll talk about that later. But for right now, let's move these 4x's so they're no longer on the left side. That means we have to take them away or subtract them. So subtracting 4x from both sides gives us 4 is less than or equal to 9x minus 4x is 5x, and we still have 8 on this side. Now, we want to isolate x, so we're going to take away that 8, subtract 8 from both sides, and we get negative 4 is less than or equal to 5x. And then we can divide by 5. If we divide by 5, we get x all alone, and we have negative 4 divided by 5, that's a fraction, negative 4 fifths. Reduce any fractions to lowest terms. Well, 4 is not divisible by 5, it has no common factors with 5, so that's as simple as it gets. And our result is negative 4 fifths is less than or equal to x. Now, I can enter that as my solution, or if I wanted to put x first, when you have an equation you can flip-flop them, because if one thing is equal to the other, then you can say the other is equal to the one, right? So that's not the case here. I can't say that this number is less than that one and then just flip sides without changing my symbol. Okay, so if this number is less than or equal to x, then x must be greater than or equal. So I can write that. X is greater than or equal to negative 4 fifths. All right, so I can enter this inequality, and that's also an expression of my solution. Okay, so x is greater than or equal to negative 4 fifths. And we can do this next one. Solving for m. So we want all our m's on one side. Again, it's a good idea to make them positive. So let's add 87m to both sides. That'll give us 95m plus 95 is less than 5. We want the 95 to get away from the left side of the equation, so we'll subtract it. Subtract from both sides, and we get 95m is less than negative 90. And then we want to divide by 95, and that will give us m is less than negative 90 divided by 95. Now, they want us to reduce fractions, and both of those numbers are divisible by 5. So we'll reduce by a factor of 5. 90 divided by 5 is 18. The fraction is still negative. And if 90 divided by 5 is 18, then 95 divided by 5 is 19. So we have m is less than negative 18 19ths. All right, we can enter that into our answer box, but before we do, I want to point out what would have happened if we had instead made our m's negative. Let's look at that way. So if we subtract 8m from both sides of the equation, we would get negative 95m plus 5 on the right side of the equation, and we would be left with 95 on the left side. If we subtract 5 from both sides of the inequality, I should say, not equation, it's an inequality, I would get 90 is less than negative 95m. Now compare what happened here. We've got the same numbers, the same values, right? There's a 90 and a 90 and a 95 and a 95. There's an m and an m, right? But in this equation, positive 95m is less than negative 90, and in this equation, negative 95m is greater than 90, right? So if I divide by negative 95, I will get m all by itself. And if I divide by negative 95, I'll get negative 90 over 95, like so. But what should my sign be? When I did it this way, I have m is less than that amount. I can't just keep that symbol going this way, because that would mean that m is on the greater side, and this is on the less side. So if you're going to divide by a negative number, you have to remember that you'll have to switch the direction of your inequality sign. Because what you're saying essentially is the opposite of this number is greater than that number. Okay? Well, if the opposite is greater, then the number itself must be less than, right? If the opposite of m is greater than that, then m must be less than that. That's another way to think through the logic. But I find that a little confusing, which is why I prefer to always just keep my variable positive in the problem, so that I don't have to switch the direction of the sign when I divide by a negative. And we're going to enter our answer here, which was what? M is less than negative 18 19ths, just like that. And we are done.